Okay. Good morning, one and all. We'll start the today's session. I, on behalf of Jain College of Engineering, Department of Computer Science and Engineering, welcome you all for this 3 days online faculty development program on emerging technologies in IT industry. So this 3 days FDP we have scheduled, and there are 3 sessions. Every day we will be having one session from 10 a.m. to 12 noon. Today is the first session we are having on deep learning for audio analytics by Dr. T. Senthil Kumar, Associate Professor, Department of Computer Science and Engineering, Amrita Vishwavidyapitham, Coimbatore. Tomorrow, that is 29, we have a session on Openstack cloud computing by Mr. Dharavath Suresh, Senior Software Engineer, Radisys India Private Limited, Bangalore. And the last day, that is on 30th, we have a session on Global Technology Trends in IT Industry by Mr. Nagaraj Chinni, Lead Architect, IBM, Bangalore. Once again, on behalf of Jain College of Engineering, Belgavi, I welcome all the participants. Resource person for today, Dr. T. Senthil Kumar, our beloved Principal and Director, Dr. K.G. Vishwanath, and all my dear colleagues for this 3 days faculty development program. Now, without wasting much of the time, I request our beloved Principal, Dr. K.G. Vishwanath, sir, to give his opening remarks. Over to you, sir.
Good morning, all participants. Very good morning to all. Dr. Senthil Kumar, Amrita Vishwavidyapitham.
Yes, sir.
Dharavath Suresh, Mr. Nagaraj Chinni, and all the participants who are participating from all over India, actually. So today we are inaugurating the 3-day faculty development program on emerging technology trends in the IT industry. So these days, in the past 2 months, we have all seen how technology is being used to integrate teaching learning remotely, as well as the entire world is shifting to an online mode. And of course, at this juncture, the use of technology is getting a very prominent role in connecting the people. And we can also see that the entire world has got shrunk to a one platform, or maybe entire world is one now. Irrespective of our locations, we can interact with the people, we can talk with the people, or we can even share our knowledge with the people through the use of technology. It is not only that, the entire world is utilizing more and more advancement in the technology, and is also demanding more and more advancements in the technology, so that the use of technology should be made available to the common people, and everybody is getting trained in this. So keeping these points in mind, we thought of organizing a faculty development program where a few topics can be covered which could be of help to everyone. So this day we are starting with the first session, where on deep learning for video analytics will be discussed by Dr. Senthil Kumar. And as just now Praveen Chitti mentioned, tomorrow and day after tomorrow also we'll be having 2 more sessions, where cloud computing and global technology trends will be discussed. And of course, this is not just the entire thing. Maybe with your active involvement, you can pose an interaction also on this platform. So let us have it interactive, and of course, it may not be that interactive as we used to do in an open classroom, but still these restrictions, whatever we have with online, could be overcome again with the use of technology itself. I hope these 3 days you should be able to utilize and then have an active participation without any break in between. Of course, I know most of you will be having a lot of other assignments also, but spare this time and concentrate on the things that will be deliberated in these 3 days between this particular scheduled time, and get actively involved. And then the takeaways from this 3 days sessions should be of use to you in your regular day-to-day affairs. As well, maybe we should be able to look forward in using technology to a greater extent in the days to come or years to come, because as you all know, COVID could be having a very long life than what we had thought earlier. So the use of technology is surely a requirement of the day and a requirement of the future also. I hope we should be able to overcome these disturbances or these difficulties with the use of technology platforms. With this, I'll uh, give room for the today's speaker. So over to you, Praveen.
Thank you, sir. Thank you for your opening remarks. Now we'll start with the first session of this FDP. Before we start the first session, I want to introduce the speaker for today's session. Dr. T. Senthil Kumar is the resource person for this today's session. He completed his BTech in Computer Science and Engineering from Setu Institute of Technology, Madurai. He then completed his MTech in Distributed Computing System from Pondicherry Engineering College, Pondicherry. He completed his PhD in Information and Communication Engineering from Anna University, Chennai. His area of interest include video surveillance, deep learning, cloud computing, software engineering, video processing, wireless sensor networks, big data computing, embedded automation, etc. Currently, Dr. Senthil Kumar is working as an associate professor in Computer Science and Engineering Department at Amrita School of Engineering, Amrita Vishwavidyapeetham, Coimbatore. He has received appreciation in Indian Express for agent-based programming for banking domain. He has various publications around 14 international journal publication, 12 national conference publications, 9 in international conference and 14 in international journal. He also has edited 2 book chapters. He has publication in 19 Scopus Index publications. He has published a book on C++, and Dr. Senthil Kumar is a reviewer for many international journals, including Elsewhere, Computers and Electrical Engineering Journal, IEEE, Access, etc. Dr. Senthil Kumar has over 2 decades of experience in the field of engineering and technology, and I am sure definitely with his wisdom, all the participants will take something from this 3 days workshop which we have arranged. Once again, I welcome Dr. Senthil Kumar for this FDP program on behalf of Jain College of Engineering. And now I request Dr. Senthil Kumar to take over the proceedings. Over to you, sir.
Okay. So good morning, sir. Am I audible?
Yes, sir. Yes.
Yeah, fine. So I will share my content. Hope the slide is visible, sir.
Yes, sir. Yes. So you can make some show so that it will be bigger.
Yes. So good morning to you all, and regards and lot of concerns. I place it to the institution for getting me on board to take a session on deep learning and video analytics. First, I would like to thank the principal, then head of the department, for getting me on the session on deep learning and video analytics, and my lot of concerns, and thanks to Amrit Kumar because he has been coordinating with me for a month and ago to understand the topic and the delivery model. With this, I would like to start through the session. What I'm planning to take through is for you to understand what deep learning is and how deep learning can work with video analytics. So my acknowledgements to my bachelor students, then master's students in engineering who has been working with me and starting new problems in video analytics also. And my acknowledgements to my PhD scholars. I have 5 PhD scholars. All 5 of them work on deep learning. 3 of them work on video analytics with deep learning, and 2 of them are working on network intrusion detection with deep learning. So there we are concentrating on behavior security. Third, I would like to place my thanks to my industry connects, especially people in Intel, because industry is one place where we can learn things quicker. When we are hit with some problem and we have a doubt that whether the problem is interesting or whether the problem is solved, then the industry persons are the right people to give us a help. So their industry connects have been helping me a lot. Now let's take through the session. So usually when there is a problem that needs to be solved, there is a common question that what approach should I go for? So learn it from computer science. People will say that I know artificial intelligence, I know fuzzy systems, deep learning, pattern recognition, transfer learning. Whatever we have learned through properly will come in front of us to say that you can solve this problem with the concept that you know. It can be either something from AI or something from deep learning or something from transfer learning. So the left side of the slide, what you can see here is a connectivity that I want you to show that artificial intelligence is always connected to any other field wherever you want to reason a problem. So given a problem, when you are interested to map the problem as a learned knowledge and you want to give your understanding from the problem, then artificial intelligence is the best way of solving it. So the common definition goes like this. Artificial intelligence is the way in which you make computers to think the way in which the human beings think. Now, if that's the case, then we have come across different fields like data mining, machine learning. Now we talk about deep learning today's session, and people are now starting to talk about more about transfer learning and so on. So now if this is all there, then the next question would be like, what is a common factor that will try to say that this is different or this is same along the same journey, right? Now, given a problem, if you are interested to solve, please always look at the problem and see whether it is a solved problem or an unsolved problem. Let's talk about systems like face recognition. It has been a software which people have been trying to develop in the last 20 years. So it is a solved problem, right? But if you talk about problems like COVID, all of us are interested in knowing like when will the graph of India come down, right? So there is a lot of uncertainty in the data. If you go back in December and start watching the data of India with COVID, all of us would have got the information or a guess saying that, okay, it starts with China, it is not going to come to India. Now, when we started hearing that India is also starting to get the COVID cases, then our input was we have only small numbers. Now, when we started looking back and started to see now every day, we see that numbers is something like 1,000, something 5,000, sometimes it is more than 6,000 and so on. So there is an uncertainty to the data, right? And somebody is developing a model which will actually be able to predict the COVID cases, then it is not a solved problem, it is an unsolved problem, right? So if you have gone back to December, taken a Chinese data set of COVID, and if you have come up with a model, let's take it as on k-means or an algorithm based on support vector function, and if you have solved it using your COVID data set, then you would have got a lot of appreciation because it is an unsolved problem. So what I keep it to the audience is like, whenever you're interested in solving a problem, please always have a look whether it's a solved problem or unsolved problem. If it is an unsolved problem, then any aspect of computer science subjects, whichever you have come across, it can be machine learning, data mining, pattern recognition, deep learning, you can always apply it to the particular problem and solve it. But if it is a solved problem, like I say, face recognition is a solved problem. So if I'm going to go for face recognition as a solved problem, then the challenge is not about applying just data mining or any other algorithms. The challenge is in applying is more concerned about how are you improving the requirement of the use case. So what is a use case? Let's try to understand. In software engineering, we say that any small user story which can be illustrated to the customer can be called as a use case. Now let's talk about a face recognition problem. First, when you put your face in front of your camera, you can see an ROA coming in front of yourself, right? Now, if it is easy to find an ROA when the face is towards the camera. But let's talk about a scenario like this. Somebody is walking on the road and they suddenly fall down. And it is around, let's take 8 o'clock. And there's a light facing towards a person's face as a person falls down. But the light is showing only one half of the face, but the other half of the face is not seen. Can you find a face of the person and quickly inform the police and the healthcare department? There, the use case becomes interesting and challenging. So, a solved problem can become interesting associated with a use case. There, what we are interested in finding out is see only half of the face, but that half of the face again would have a lot of noise, maybe the dust on the face like that. So I need to develop a model for pre-processing to remove the noise. Then after that, I have to give it to the model, and the model has to say that, yes, I have found this is a person. I am informing to the neighbors or the relations of the particular person's house. So there we are interested in seeing a technique which will improve the accuracy of classification. So there deep learning is a solution. Hope audience are able to get this. So given a problem, please see the problem. If it is a solved problem, then there is a need for improving the accuracy of the problem. There we will go for deep learning. Now the slide on the left side bottom will actually give you the picture of a neural network. So what's the concept of a neural network? Given a set of inputs, each input is associated with a weight, and the weights are fixed based on the inputs. Now, what you're interested in finding out is like you're interested in finding out the summation of the product of the inputs and the weight. Together with the bias, we check what threshold it falls in. Based on the threshold, we will be able to say to which class it is belonging. This is a general theory of neural network. Now come to the deep learning on the right side. What deep learning will say is like, I'm giving you a set of inputs, as you can see in the first one. I'm giving you some layers, but the layers are more than one. This is the keyword behind deep. When you say deep, that means the number of layers are more. Now, as you can see on the right side, we have indicated clearly that this is first hidden layer, and this is second hidden layer, and what you see here is an output. So, the interesting part is like people will usually ask how many layers can you have? Number of layers in your deep learning model can increase. So when the number of layers increases, what is the advantage? The amount of learning also increases. So that is what is connected to deep learning. So deep learning gives you a difference from neural network saying the number of layers can be more than one. Each layer can have its own characteristic for learning. Now let's see what a deep learning does. If you run a deep learning model, given a set of inputs as you can see here, it actually has a set of weights which are provided in the first iteration. Now the weights will associate with the layers and start learning. Once it is learning, it will come to the output and then it will check what is the class it has found. Now the class it has found, if you want to conclude that the classification is correct, then what is the possibility is you can check with something called as a loss. So deep learning gives you a facility to check the loss. If the loss is high, what you can do is you can actually backpropagate the same model. That means it will go back and run again from the beginning. But this time what will happen is it will go and change the weights. That means the weights are adaptive. If you're going for neural networks, the weights are not adaptive. It is fixed weights. But in deep learning, what will happen is the weights will be adaptive. That means whichever weight has participated to learn the given data will alone be considered. Whichever weights has not participated in learning the given data for extracting the knowledge will not be participated in the forward propagation. So again it runs, again it checks the loss. Even if the loss is not going to be reduced, again you can reiterate and you can start. So this keeps on going and this gives you a keyword called as epoch. What is epoch is the number of iterations for which you want to run the model until your loss is getting minimized. So this is the strength of deep learning. So deep learning in summary will give you multiple layers compared to neural networks and okay. Deep learning in summary deep learning in summary will give you more number of layers. Each layers will give you the possibility to say, I have learned some more data. Deep learning will give you a loss function, which you can evaluate at the output. And deep learning will give you epochs. That means you can run for more than one number of iterations. So in the forward process, what happens is the weights are adjusted and the loss is calculated. And in the back propagation, what happens is the gradient approach happens and the weights are again adjusted in such a way that the output is classified to the appropriate class. I will continue the session, then I will have the questions at the end. Okay. This is again a connectivity slide for all the concepts that we are talking about. Artificial intelligence, then machine learning, and next is deep learning. When you look at this slide, you will start seeing a keyword called as labeled data. And now we are in a position to start learning some more concepts with respect to data. Let's walk through the concepts. Okay. Yes. Now what I'm showing you before you is an example of a data set that is being prepared. This data set shows that there are columns. Each column has a set of values. So what you will be given to a deep learning model or what you will get in a real-time problem is either images or you might get videos or you might get a data set like this. Now when you get a data set like this, we have to go and analyze the data set. Each column here that you can see is called as a feature. So if I ask you how many features are there, then the people will say it is equivalent to the number of columns in the given data. Now the challenge is, if I have given a data, now my challenge is I have to develop a model and that model will classify my data into a corresponding class. So the last column after the feature set will be something called as a class. So as you can see in the slide here, this is a class label here. So the challenge is, like, I want to develop a model wherein if I give a data, it will correspondingly associate it to a respective class. If I start seeing how many class labels are there, then I can see there's a class label called as 1, there's a class label called as 0. That means it is corresponding to 2 classes, right? Suppose in this data set, if I see a third class, let's take 0, 1, 2. Then I say that the data is belonging to any of these 3 classes that is called as 0, 1 and 2. Now the next keyword I'm keeping in before you is something called as feature vector. What is this feature vector? All the features that you are seeing in this Excel sheet separated by comma, if you can provide, it's called as a feature vector. So if I have all these features, right, separated by comma, then what I'm able to provide is something called as a feature vector. Now the challenge is I may have n number of features. I'm not interested in using all the n features. So I may be interested in reducing the number of features. So the concept is something called as dimensionality reduction. So what is dimensionality reduction? Given a set of features, I'm interested in reducing the number of features. I can use some algorithms for it, which is called as dimensionality reduction algorithms. Example of dimensionality reduction algorithm is principal component analysis is one example of an algorithm for it. Now, why do you need a dimensionality reduction to be done? For example, let's say you have a mark sheet of a student and there is a roll number and with 5 subject marks. Now, if I ask you, okay, right, just try to give a dimensionality reduction, you would start seeing what are the features. Features are roll number, name, and 5 marks. So what is the dimension here? People will say it's going to be 5 features, right? So the feature vector size is 7, right? So if I am interested in knowing like number of dimensions, dimension is equal to number of features minus 1, right? That means it is 7 minus 1, which is equal to 6, right? 7 minus 1, which is equal to 6. So now given dimension as a challenge, I'm interested in reducing the number of features, then possibility of doing it is like I can actually say, instead of giving all the 5 marks, you can give the total of the student. So it becomes roll number, name, total. So roll number, name and total is useful for understanding where the student is standing in the particular class. Suppose I want to take the same thing to a placement, the company will ask me like, just give me roll number, name and give me the percentage of the student. That means I'm interested in calculating a new feature which is called as percentage, which will be calculated from the total set of marks for the particular student. So I have roll number, name, percentage, right? So analytics analysis always has a question here. What is analysis? What is analytics? Analysis will give you some sort of statistics like this. Like I see a report card, I see the total, I'm saying that, okay, I found the total to say the student ranks in the class as 5th or 6th out of the 60 students. This is called as analysis. What is analytics? Analytics is more about predicting the given data. If I have the semester 1 mark sheet of a particular student, will I be able to predict where the student will stand in the next semester, right? Is called as analytics. I think people can understand. So for analytics to happen, you need to first classify. Without classifying the data, you cannot do any analytics. So first I have to classify, saying that this student is something like a student who studied with me last year, who got the same performance. So I have classified the student to be a student of type X who studied in the last year. So my analytics will be able to say, given the mark of the first semester student, I'll be able to predict what the mark of the student will be in the next semester, right? This is what analytics is all about. So for analytics to happen, I'm again saying you need a classification. Only when you have a classification, you can actually do some analytics. Now, if you look at this data, this data will give you a lot of challenges and questions. Now, for example, each column has got its own challenge. Some are numeric, some are decimal, some are negative, right? As you can see here. And if you are looking at the columns, there is a possibility for you to say, I have one column here, right, where the columns is having characters, right? So it is a categorical data. So if I want to compare two numbers, it is easy, but if you want to compare two data which is categorical, it is hard. So what people suggest is, categorical data is also not a solution. So what people can actually go about is, they can go through some approaches like one-hot encoding, right? Let's take a one-hot encoding approach, right? And using that, they will be able to convert the data into a numerical data. So this is the next information I'm keeping before you. Convert your categorical data into a data which is numeric based on approaches like one-hot encoding, and then you can run through your model and you can classify your data. Fine. So now you know what is features, what is feature vector, you know what is the solution for converting a categorical data to a numerical data, and you know what is single class and you know what is multi-class. Now the next thing which I'm keeping it before you is the process that you generally do in the pre-processing. If you're interested in pre-processing a given data, then you have to look for noise. For example, in the first column of the data, you can find that there is a value called as 0. So it indicates a noise. So you're interested in changing this value to a value which would be something similar to this. So one possibility of doing the same thing would be, is like people will say, I will be interested to do an average, right, of all these three data, and I have found my new data, right? So a value which is going to have a noise can be applied with some approaches through which you'll be able to generate a value. Now, if you ask yourself, what is this value? What is the interpretation of the value? This value as such would be a value which can be from a stock market. This value would be a value which is a feature which you have extracted from some image or a video data, or this value would be a value which is corresponding to some activity in a given video data, right? Now, pre-processing is a very important step, and modern approaches have come for pre-processing. And people are now looking at deep learning as a possibility to enhance the deep processing approach, right? So this, I want you to just have a look so that you understand certain keywords to deep learning. So given some data, what is labeled as a class that you're providing to the data? Now, let's come to the next part. Now, the challenge is, I'm interested in having a data which is an image or a video or an CSV file, which is an Excel sheet that we just now saw. I'm interested in classifying the data. If I'm interested in classifying the data, it can be classified as a two-class or it can be classified as a multi-class. Once the classification is successful, then I can say that I have got a training data ready, right? So what I'm trying to keep it before you for your discussion is like this. Now let's take you talk about your Excel sheet that we have been trying to discuss, right? If the Excel sheet data is not going to have a class label at all, like for example, if you can see here, this is my class data, okay? I don't have any class label at all. That means it is empty. That means the data is fresh. I don't have a class label. I don't have a knowledge representation for it. Then I go for some algorithms from unsupervised learning, and with that, I'll be able to populate and say, I have found a class label for each of this data. Now, in this records, all these data have a class label value. So this becomes an example of a training data. So your training data is essential because it gives you some knowledge. Now, with this training data, if I want to know what is a class for this given row, right? I can use some algorithm from supervised learning, which can be something like k nearest neighbor. With that, I'll be able to say what is a class label it belongs. I think people should have understood what is unsupervised learning, what is supervised learning. Summary is like this. You get the data and the data is not having any class label value. Then you have to go for unsupervised learning. Like this, I have a data, no class label value. So now I want to find the class label value. I have to go for a unsupervised learning. Suppose there is a class label value already available, right? I have a data, fine. My class label value is available. Now I want to find the class label values for the remaining rows. I have to go for supervised learning. The next thing which people should always understand is data as such, even if it's an image or a video, there is always possibility for you to generate some metadata like this. Okay, this metadata is something relevant to the features from the given video or the image, right? For example, last 2-3 days we were able to get some information that there is some sort of insects around the region in some part of the country. Now, if you take about an aerial image from there with a satellite, it will actually show you the land regions covered with a lot of insects, for example. So the image, if you talk about the image, let's take a month ago, it would have been greenery. Now, if you talk about the same image that you're acquiring from the region for the last 1 or 2 days where the insects have come, it will be still greenery, but with a lot of different colors. So you get some numerical values, which you can call it as features, and that features can be populated as a data like this. So what I'm keeping forth for your discussion is like a data that you look at can be an image or a video, and from there you can actually generate some supportive features which can become part of the data here. Now, what I'm showing you here is a classification scenario. Given some data, I want to classify my data to a specific class. Now, right side, what you can find is something called as regression. So, and you can see something called as clustering. Whenever you have a data, please go and see whether your data is a continuous data. If your data is continuous data, right, then what you can do is you can go for a regression problem. For example, if you talk about a COVID data set, right, then the COVID data set is an example of a continuous data, because if you talk about December we didn't get any cases, right? But after December, what is happening is we are getting a lot of cases every day, even in the morning, afternoon, and evening, right? Okay. So what you can understand is, given a data, if it is going to be continuous, right, then you can go for a regression problem. So please always understand, please do not use a discrete data and try it with a regression model, right? So given this as a information in front of you, now the question would be is like, I have a discrete data, then what I'd be interested to do is I can go for clustering. So clustering is a very popular approach. It's a very old algorithm. Let's take k-means clustering for example. But still, given some data, if you want to know the way data can be mapped into the respective classes, or if you have a question how many classes can come up in the data, then clustering is a good solution for it. As you can see in the slide, you see 3 clusters. Each clusters have their own properties. It depends on the data that you're working. Now the discussion is more about, not about the data, the more about the understanding of anomalies. For example, if you talk about your COVID data, people will be interested to know why the curve is going high, when the curve will come down. So the curve is not going high, then it is not an anomaly for us, right? Let's take you talk about a heartbeat. Heartbeat is going high, then it's an anomaly. So any data will give you something called as anomalies. So what is anomaly is something which is not natural, which is not normal, which is not normal to occur in the data. Then what you can do is like you can actually understand it is called as an anomaly here. See, deep learning always gives you one more keyword called as feature engineering. Now let's see what feature engineering is. For example, if you can see on the right side, as you can see in the slide here, you can understand that there is a cat image, and this cat image is given as an input to know whether it's a cat or not. What your deep learning is going to do is it's going to have through an input, it's going to have a lot of hidden layers, and it is finally going to say it is a cat or not. How many hidden layers you're going to have, it depends on the problem that you have. Now, the challenge is more about here is, if I'm going to give a cat image like this, it's having a lot of pixels. So my first set of features is something called as pixels. So group of pixels, I can call it as an edge. That means I'm finding new features using feature engineering, which is called as an edge. Now, all these features are white in color in a region. So I found a new region. Region becomes the next feature. Then I see that there are two circles, but both are black in color, right? I can assume that it would be an eye, right? So features that are found at every iteration can be connected to the new features and the information can grow. This is what is called as feature engineering. So deep learning as such has a capability that at every layer, it can learn a set of features and it can create new representations for understanding the features are more related to the data. Like I said, pixels, group of pixels are edges, group of edges is called as regions, regions with a corresponding knowledge capability. You can say it is in face, and then you can say it is a cat or not. Right. So these are the keywords that we have kept for your discussion now. We know what is features, we know what is feature vector, that is group of features. Then we know what is dimension, that is number of features minus 1. Hello? Hello, am I audible?
Yes. I request all the participants to mute your audio. Sir, continue, sir.
Yeah, please, sir. So if I have 5 features with me, now my challenge is I don't want to use all the 5 features. I want to reduce my number of features. So it's called as dimensionality reduction. So as I told you, if I have image, then with the image, I can form features, first level features as pixels, but pixels will correspond to the size of the image, right? Number of rows with number of columns together. Now, the features with pixels can be understood as edges, where the dimension is getting reduced. Edges connected, I can call it as regions, then the dimension still gets more reduced, right? So this is what we can understand it as dimensionality reduction. Then class label, as I told you, the last column in the data would be called as a class label. So you can always start your problem as a single class, 2 class, or a multi-class. For example, if you're teaching to your kid, okay, let's take you teach your kid what is an apple. So you show an apple in front of the kid and say that this is an apple. The kid understands, okay, it is red in color, it's got a shape like this, okay, and keeps a mapping to the mind. Now, if you bring a mango and show it to the kid will say, it is not an apple, because what the kid knows is only apple. It is called as a single class problem, right? But the same kid, you are showing and teaching, no, from today you should learn what is mango. Show a mango in front of the kid. The kid understands, okay, it's yellow in color, it's also a region, but the shape is different from an apple. So shape becomes one feature. Now the kid knows 2 objects, one is called as an apple and next is a mango. Now if you show an apple in front of the kid will say it's an apple. You show a mango in front of the kid will say it's a mango. It's a 2 class problem, right? Now the same thing can becomes increased. You can show a papaya in front of the kid will learn, okay, papaya is larger in size. The kid maps, okay, the area is larger. Okay, we call it as area, but the kid understands the bigger size. So if you show a papaya in front of the kid will say, it isn't papaya. Or the kid knows 3 classes, 3 objects, right? So this is what is called as classification. So given a data with set of features, what you have learned from the given data, the challenge is to map it to the corresponding class. Any problem will start with a single class problem. For example, if you go to a doctor, the doctor will ask you, like, what do you have? You say, sir, I have a fever, right? I have a temperature. Then the doctor says, okay, you have a fever. Now you go to the doctor and say, sir, I have a fever, but I have a back pain also. Now the doctor is confused. A fever with a back pain. Okay, it can be a new symptom, for example, right? Okay. So any problem starts with a single class and can always become a multi-class, right? Now, other keyword which I'm keeping in for your discussion is something called as interclass and intraclass. If you go to a doctor and say, I have a fever and I have a pain, right? The doctor distinguishes fever is different, pain is different. So fever is one class, pain is another class. Okay. So this is something called as interclass. Now you go to the doctor and say, sir, I'm having a fever, but last 2 days the temperature has not come down, right? So the doctor understands, okay, the person is having a fever, and under that the doctor goes back and says, you do a blood test, maybe you may have a dengue or you may have some other type of fever. So there it is called as intraclass, right? So the doctor now has a confusion whether it's a dengue or a COVID. Let's take for an example. So dengue COVID comparison is an example of an intraclass problem. So most of the models will actually starts with interclass and then come to intraclass models, right? So your algorithms that you would look at, maybe machine learning or deep learning, should be able to say, I give you solutions for both intraclass and also interclass. The takeaway points for you for deep learning is something like this. Given an image, what we want to apply is something called as a filter. The filter is understood as a neuron, right? Now, if you have an image with you, right, the input of the image will have a size. The size is understood to be 32 cross 32 in this example. Now this image is going to work on 3 matrices, one for red, one for green, and other for blue. So you have 3 matrices with you. So your input image matrix is represented as 32 cross 32 multiplied by 3. 3 indicates your R, G, and B. What you want to apply next is a filter. So filter as such can start with the arbitrary size greater than 2 cross 2. Now here we are talking about a filter of 5 cross 5. Now again you need a filter for red, green, and you want to have one for blue. So your filter is going to be 5 cross 5 into 3. After you apply the filter on the given input, what happens is it does a convolution operation. So once it does a convolution operation, what happens is it gives you a resultant value matrix, which we call it as an activation map. This is called as a feature map. This is what I was saying you, from a given image, if I have a filter with every layer, I will be able to learn some features, which is called as feature engineering. Now, given an input of image of 32 cross 32 by 3 with a filter of 5 cross 5 by 3, what I will be able to get is a resultant matrix, which will be like 28 by 28 multiplied by 1. Okay, right? So you'll be getting certain number of locations, which will be equivalent to 784, which is 28 cross 28 multiplied together. So now the challenge is, when I have learned something, then the learning behavior also can change. How it can change? For example, let's take, I have these 2 operations from my deep learning. This is already there in theory. One is called as stride and next is called as padding. Now let's take you, all of you are looking at your monitor, right? And your face is towards the left side. Then you will say, put your filter on the left side of your frame and find my face, right? You say, no, I'm studious, I'm sitting straight, I'm looking at the monitor. Then my face is in the middle. Have my filter in the middle of the face and then say whether the face is being seen or not. So the first operation is something called a stride. What will stride will help us to do is, it will say, how can you put your filter on the given image? Can I put the filter in the left side, right side, middle? Where I want to put, I can specify. It's called a stride. The next one is something called as padding. Not all cases, the data that you can work is actually a square matrix. But please understand, deep learning was introduced only for images. So it needs a square matrix. So what you're supposed to do is, you're supposed to fill all the remaining columns as zeros, which gives you something called as padding. So these 2 operations will actually say, how can you do the operations at every layer, right? Now, as I told you earlier, you start with your deep learning from the input to the output. What you do is a forward pass. And what you calculate is something called as loss. So every time it will say it is belonging to a class of X or class of Y.
So what you get is something called as actual. But there is an expected part. Like you give a cat image, it should show you a cat. That's unexpected. So the difference between an expected and actual can be found as something called as loss. If the loss is high, you ask your deep learning model to start again from the beginning. That is, a second iteration starts and goes in the forward process, calculates a loss. This is something called as backward pass. And in that stage, what happens is the weights gets changed, as I told you. Weights which are contributing to extracting the information will be allowed, and weights which are not participating in information extraction or knowledge representation will be automatically removed. It's called as parameter update. When it happens, all we are looking at is, can we learn the data and appropriately classify with higher accuracy? That means the loss is expected to become minimal. Now, when you are looking at a model on deep learning, then there are a lot of performance measures that will come up before you. Usually, when you talk about the data from where we started, right? For example, if you look at the data here, which we started, we said we have set of features. But somebody would always go and say that each feature, right, belongs to some type of data. Some type of data means what? Something would be a positive sample, something would be a negative sample. For example, all these are features corresponding to an image for a cancer cell. Let's take it like that. Let's take, we understand that this first row, right? This first row that we talk about belongs to a category of C, that is a cancer cell. This is not for a cancer cell. This is for a cancer cell. This is for a not cancer cell. So now we are in the challenge to say, I'm training my model not with the good thing alone. I'm training my model with something which is not to be known also. For example, I need to know only cancer cells, right? That means it becomes an anomaly. But my model also had to know what is not a cancer cell. This is an example of features for a not a cancer cell. So your model should be trained with positive and negative samples, right? Now, people will usually ask a question, which needs to be more important. For example, I'm training my model with more of data which is not a cancer cell. Let's take it like that. Now, somebody is coming for diagnosis, okay, and he is not having a cancer. Fine. So he is diagnosed as not having a cancer. Not a problem, right? Okay. Now, the next challenge is somebody comes in and he is not having a cancer, but my model by mistake classifies that he is having a cancer. Okay. Like what I'm saying you here. This is supposed to be a non-cancer cell data. It classifies by mistake that this person has a cancer. So this is a big damage. My model is doing an injustice to the knowledge representation. So when you train your model, you should be making sure with what type of data you want to train. So you should be training with more of data which is not a cancer cell, rather than saying this is all cancer cells alone, right? So this sets you to the next slide discussion, which is called as positive and negative samples. You want to train your face image is a positive sample. Somebody's face image is a negative sample, right? So given positive images and negative images to the training process, what happens is you classify the data. Once you have classified the data, if you give a test data, I want to say it belongs to which face in the given training model. So there, if your face is classified as a face properly, it's called as a true positive, right? If a not a face image is classified as a not a face image, it's a true negative. The complementary to that is what you see it as false positives and false negatives. Most of the models, we are interested in reducing the number of false positives. Now, these parameters are the parameters that are generally there to understand why a model is popular. If I'm going for a machine learning or if I'm going for a data mining technique, then I can use all these parameters: precision, recall, accuracy, false acceptance rate, false rejection rate. With this, I will be able to say whether my model is working properly. Now, these parameters, what we discussed, right, will also come in deep learning also, but you will have some more parameters, something like false discovery rate, average precision, mean average precision, top 1 error rate, top 5 error rate. Let's see what is this keywords and why they are very important. Now, see, when you say that I'm interested in looking at a data, fine. Let's say that you are interested in, just a second, yeah. You're interested in looking at a data. Now the challenge is like, what is data that I work? This is a small video which actually shows you through a face recognition, right? Somebody's face comes up, then automatically the face recognizer will be able to say there is a face being recognized, right? And there's a tagging to the face, right? So it's a face recognition and also a face identification. Now, if you see from this video, as you can see here, I'll again put back for your information. The first person is not detected properly, but from the second person onwards is detected properly in the beginning itself. So every model always takes some time to train itself to recognize that model. Now, if your data is more concerned about whether it is a face or not, then what we talk about is something called as precision and recall. If my data is more about recognizing face and giving properly the ID of the face, then what I'm more worried about is the accuracy. Okay. So there are two keywords in front of you. One, understanding, saying that there is something called as precision and recall. Example is identifying a face or not a face. If you are interested in knowing that in this face, this belongs to so and so person name, it is called as accuracy, right? So look at these parameters. People always think every parameter can be used for everything. Not like that. Based on your problem, please look and see whether you can go for precision or recall, or you'll be going for accuracy. This is the state of what general thing. But what deep learning is can actually give you is something more. What deep learning will say is like, I will give you an approach based on a probabilistic based approach. For example, yeah, if you can see here, one second, I'll give you a higher font. Yeah. Now, if you are going for approaches which is other than deep learning, okay, let's take machine learning for example. I'm going for approach which is with machine learning. Okay. Now, what machine learning algorithm will say is, if you are giving a class data, it will say a class to which it belongs. Now, with class A is class A. That means class data labeled as A. Class B is labeled as class B in machine learning algorithm. I'm talking about output. Class C data is labeled as class C. Now, if you ask how many misclassification has happened, people will say there's one misclassification because there is a data which belongs to a class C, but it is misclassified as A. This is what a machine learning algorithm can do. But now, when you go to deep learning, what deep learning will say is something like this. Deep learning will say, you are giving me a data. I will classify the data to all possible classes because a deep learning approaches are stochastic approaches. That means they are probabilistic approaches. So I given you a data of with class A deep learning will say, I can say it is A in the first higher probability, but still it is B in the second higher probability, still C in the second higher probability. Now, same for all other classes, right? Now, if I go for deep learning, a class A is classified as class A in the top one accuracy, as you can see here. But B is not classified. Third one is also not properly classified because C is classified as B. But if I'm going for the top two classification level, I will say that A is classified as A in the first two higher probabilities. Second one, class B is classified as B in the first two higher probabilities. Class C is not classified as C, right? That means if I go through this top two order, my level of classification understanding increases because I'm able to classify the first two instances, that is class A is class A in the first two, class B is classified as class B in the first two higher probabilities. This is what deep learning is. So deep learning is more of a probabilistic approach. Okay. Now, usually people always understand this deep learning and have discussions on what generally is a process. You talk about any data that you want to solve. Now we are looking at a video data. So the first step that would happen is I'm interested in collecting the data. So where will I get my data? go around, do a crowdsourcing, get the data. If your data is fresh, then as I told you, it is an unsolved problem. Whatever you are trying to do will become the first step to the research. The next is data pre-processing. That means you are interested in seeing what is noise, what is outliers in the problem. Third is what are the parameters that you want to set. Now, before going through the parameter assignment model, let's see through this video and understand this keyword. What is video analytics? See, video analytics as such differs from a keyword called as video analysis. What is video analysis is something like this. Let's take, I have a video. I want to count the number of people who are coming in the video, right? I see, okay, 1, 2, 3, okay, right. This is an example of analysis. Find the count of the number of people entering the door, okay? Now, analytics would be is something like this. My analytics problem would ask, why was the first person not recognized as a face in the first iteration itself, right? So analytics is more about something from the past data. So if I look at this, then I'll be able to conclude, or I can give an inference saying that this video was a faster video, this video was a slower video, or the person motion is high, because of which the person is properly seen. Or I can conclude that there's a lot of time the person face appears on the camera. So my analysis is becoming something called as analytics. So video analytics is more about prediction. Okay, analysis is more about just understanding of the given data. Now, video analytics is a very interesting field. People always bring one more keyword below that, something called as image analytics. So what would be image analytics is something like this. Let's take you have a video or you have a frame data in for you. Now, in the frame data, if you are interested to know what can be the possible challenges, for example, let's take here, I'm talking to you with the next application here, which is more about license plate recognition. Now, if there's a camera and the camera is able to take some license plate in front of you. Now, what I would be interested to know is like, once a car comes in, I'm interested to know what is the number plate of the car. Okay. Once I know the number plate of the car, then I'll be interested to know what type of car it is. That is, whether it is a car belonging to a normal person or whether it belongs to a VIP or whether it belongs to somebody else. Third would be like, I'll be interested to know whether the car as such, right, is able to give some information whether a car is a stolen car or not. Now, this is an example of a person detection, as you can see here. As the person walks, the ROA also is able to detect. That's a region of interest is able to detect. Now, once the person is walking, right, as you can stand, bend down, everywhere, what happens is the ROA is able to find the person properly. Now here, it gives you a count, as you can see here. What is a vehicle, right? And then it starts numbering the vehicle with a given ID. So what is analytics is all about is first identifying something from the data. And after identifying something from the given data, give an ID for it and help us to do some analysis further. Now, what would be an analytics more about in terms of person detection? Like what we have seen you here is like, what will happen if there's a location where there's a lot of crowd, right? Now you can see that there's only two people walking, right? Two people walking together. Now, if you look at a COVID situation, we are interested in keeping people 1 feet away from each other. Can you develop a model which will say the camera from a longer distance will say this person who is walking with the next person, right, is at least 1 feet away or not, right? This is something called as analytics. Okay, so analytics is more about using algorithms from image processing, video processing, with algorithms that you know from machine learning, deep learning, or transfer learning to reason some knowledge from a given data. Data here is an image or video data for our understanding. The next one is something called as the parameters that you want to assign. there are a lot of parameters that are generally assigned, right, for a model. But few parameters I would ask you to have a look, because you should be knowing the purpose of these parameters. See, when you are given a problem to be solved and you have a lot of deep learning architectures in front of you, my suggestion would be is to go back to this deep learning architectures and see what these deep learning architectures are special for. For example, there's an architecture called as LeanIt. These are all called as performance parameters, and these are all called as hyperparameters. Let's look at the performance parameters. What you saw from the slides will come up here: precision, recall, mean, average, precision, F1 score, top 1 error rate, top 5 error rate. Hyperparameters are one that can be changing with the model. When the model starts running, it can actually change its parameter value, right? It's not fixed. That's why it's called as hyperparameters. The general hyperparameters to a deep learning architecture would be learning rate, momentum, optimizer, and next is activation function. Activation function resembles, it's the same as activation function what you see in neural network, right? But what you will see different in an activation function is activation function for deep learning will be something called as ReLU. ReLU is the default activation function. So example of a linear architecture, your understanding would be is like precision is some value, recall, what is the sum value, what is the data that you are exploring. All this we have to do some state of art research. Then we have to go back and see what is the hyperparameters that are generally fixed. So if you are employing some other model, let's take other than LeanIt, to solve your problem, right, then your new architecture should give you a more better value in terms of performance parameters, right? How do you get a more better performance? You can fine tune the hyperparameters, right? So this is the way of doing a research or a project with respect to video analytics. Given some video data, I'm interested in finding out a new architecture which can be compared with an existing architecture which is already used, wherein the performance parameters gets improved. That means precision is better, recall is better. How do I do it? My deep learning architecture will work on the hyperparameters or a way to tune the hyperparameters. This is what I told you, parameter tuning. Now, the next question people generally ask is something called a stopping criteria. When will I stop my deep learning model? One way of stopping a deep learning model is when the losses become very minimal. Or the other way of stopping a deep learning model would be is go for an iterative approach, conclude what is your objective function for your problem. Based on your objective function, you can say the model can stop, right? So if people are looking at programming, they will actually say that I'm interested in using a concept of providing number of epochs. In my program, I say number of epochs is 10. That means my model run for 10 times. So stop criteria is epochs. Some people say, no, based on the loss, and the model loss accuracy becomes improved, then I'll be interested to stop my model. Last one is something called as visualization. How can you pictorially represent your performance in terms of some graphs? Graphs could be precision graph or recall graph, accuracy graph, or any performance parameter that you have come across. Performance parameter in the sense, whatever I have shown you in the previous slide with respect to the parameters will be an answer. That is precision, recall, mean, average, precision, all that. Now, next comes the discussion on the deep learning tools. We are interested in solving a video data or a video data problem. What can be the possible way? See, this is actually left to the end user. Some people will say, I'm happy to work with Cafe. Some people will say, I'm happy to work with some third-party environment which is built on Python. But my suggestion or what my teams have been trying to use is one combination of Keras with Theano, Theano, or Keras with TensorFlow. Still, if you have a question like, should I go for TensorFlow or should I go for Theano? The answer is like this. Whatever application that you're working on, as I told you, look for the pre-existing model. If the pre-existing model is built on TensorFlow or Theano, please use that model and then you improvise your architecture, right? Or if you go from the programming language aspect, it is usually said that the TensorFlow is built on C++. So it is faster than Python, right? So what happens here is like there is a possibility for the model to be giving you a better performance, right? So that is the next reason why we say you can go for TensorFlow with Keras. MATLAB is also used, but only challenge we usually face is whatever application that you code should run on your computer, should run on your embedded devices also. So onboard porting, generally people suggest it's better to go for Python based environment. That is why I'm suggesting to go for Keras with Piano or Keras with TensorFlow. Then next, what you see here is a data collection process. Generally, all your problems will start with crowdsourcing, as I told you. You need images, you need videos, you need some CSV file or Excel file to make your data. This, you can actually go for some data sets that you see in the internet. There are a lot of data sets on the internet for your understanding. I'll show you one. This website, what I'm showing you on the screen, is from a company called as Intellivision, as you can see. This is just for you to understand what are the promising video analytics applications people are working, right? Now, coming to the data set, there are a lot of data sets on the internet. One is Caltech data set is one good data set which people can go for, right? It's a very promising data set because you get 360-degree view of a data. If you take an apple, you have 360 images for the apple in different orientation. So what I'm suggesting is first data set that you can actually look for would be one from the Caltech, right? Okay. Then next one, with respect to data set is like this. You can actually take data sets which is called as outlier data set, right? So there are a lot of outlier data sets being available, but most popular is this one, right? Which is called as outlier data sets related to anomaly. This is from the Stony Brook. The advantage of this data set is this will have lot of applications which you generally work, right? Right. So you'll have video data sets also being available. And this is a classified data set. That means you have a class label to the given data also. So what I would suggest is to go for data sets which are from the Stony Brook also.
डिस्प्ले भी नहीं हो रहा तेरा डिस्प्ले हो रहा है तो
Hello,
डिस्प्ले कर
am I audible?
Yes, sir. Continue.
Yeah, okay, fine. Now, the next one that we are looking through is understanding or developing the model process. See, models as such, as we have been saying, starts from architectures that you know. The first step architecture that you should actually try would be a CNN architecture. That's a convolution neural network architecture. Once experimenting your data set with convolution neural network architecture, you can look at other architectures which are promising to the given application. As you can see here, I have listed some architectures which are popular. ImageNet, GoogleNet, YOLO is also there. So whatever architecture that you propose with respect to your video data or your image data, you can compare with these architectures also to understand their performance. So when we started looking at this, with our team, we were interested in seeing how can you do some possible improvement in the pre-processing, right? So in that process, we did one tool which we had gone through an academic rigor process. This tool is an analytics tool that I have developed with my team of students, right? So Mukesh and Rahul. So I will walk you through the tool and then come back to the discussions. So what this tool can actually do is if somebody is giving a data, then the data as such can be understood using this tool. So let's see the characteristics for this tool. One second. Yeah, this tool is a tool that will help us to pre-process, and understand the data that we have. Right? As I told you, if it is an image or a video data also, it is actually having features. The features could be from pixels for understanding. So this tool is completely developed in Python, right? So what this tool does is something like this. If you have a given data, right, as you can see on the screen, if you have a given data, the data can be first loaded. Once you load the data, then it will ask you what is a target feature attribute, whether it is a numerical or whether it's a categorical. Let's take you specify it is a categorical attribute. Then in the next step, what it does is it starts showing more information about the data. As you can see here, it starts showing what is the data that you're working on. So the columns of the data will come with the values of the particular columns.
Excuse me, sir. Sorry to interrupt you.
Yes, sir.
Hello, sir.
Yes, please.
Hello, sir. Your screen is not visible.
Oh, sorry. Shared. So is it visible, sir? Hello.
Yes, yes, sir. Visible, visible.
Okay, thank you, sir. Thank you. Sorry.
Yes, sir.
So I'll go from the back, right? Now, what we have done is we want to start working from the given data. So let's take your data is being provided in an Excel file. It will ask for the target feature. So the target feature will be either a numerical or it will be a categorical feature. Once you specify the feature to be numerical or categorical feature, then it goes to the next step wherein it will show your data. Now, as you can see here, the data will be displayed here, showing what are the columns of the data with the values. And in one quick summary, it will show you what is the data type of each of the columns. Columns here means features. And then it will say which are all numerical features, which are all categorical features. As I told you earlier, numerical features are easy to be compared because arithmetic operations can be complied, but categorical features cannot be done. So the challenge is converting a categorical feature into a numerical feature. So next step, what happens is it asks you what is the procedure that you want to apply for conversion. So there are numerous ways of doing it. We went through some articles and research and we understood that you can actually go through a numerical encoding followed by a missing value detection followed by a scaling. So next step, what it does is it starts asking you what type of encoding you want to do. As I told you, one approach is you can go for a one-hot encoding, or you can, there's other approach called as label encoding. Let's take, I click any one of the encoding approaches, right? Automatically, it will go to the next step. It will ask you, how do you want to generate the missing value? Let's take, I say mean, median, or mode, whichever way I say. Then the next step it will ask you is like, what type of normalization you want to apply. This normalization we are applying because we want to do a feature scaling. Let's take, I click on Z-score normalization, right? Then next step, what it does is it will ask you how many number of features to which you want to reduce. This here, what we are talking about is something called as dimensionality reduction. Given n features, I want to reduce it to certain number of features, which is less than n. So many approaches are there. One approach is you can go for linear dimensionality reduction approaches, which is one example is a PCA. Or you can go for non-linear dimensionality reduction. Example, you can go for autoencoder. Now, I have my data. Now, in that data, I say I will apply for linear, that is a PCA, principal component analysis. Then it will ask you, okay, you have many number of features. How many number of features you finally want to have in your data? Let's take, I say, I want to reduce it to 7 features totally. This is a user customized. You can give your features as you want. Let's take, I say 7 features is a number that I want to reduce. Then it will start saying that I have converted the data. And after conversion, this is a success information. That means number of features that is retained. We originally had certain number of features. Number of features retained with the information is 98.52%. And in terms of storage on the system, the memory advantage we get is 21.2%. That means the original data is compressed to a size of 21.2%. And this further, we can actually go through noise detection. We can go for regression analysis. We can go for data visualization also. Right. So why we thought of this tool is like a data that you work is generally huge in size when you're going for deep learning, right? Or big data problems are huge in size. So if you have an approach where we can do some pre-processing by doing a dimensionality reduction, then you have a data which is smaller in size, so your model can actually work better. Because a lot of time people say that my features are many, my data is huge, so naturally my model data cannot run on my system. So there are some system limitations also. There we felt a point saying that if we can do dimensionality reduction, bring down the number of features, bring down the size on the system, then your deep learning model or machine learning model that you develop on a feature set will run with a faster amount of time. This is one tool that we have made. We have gone through the little prototype version. Now we are in the process of improving it to make it as a full product version. See, when you want to take deep learning to video analytics, there are many possible applications that you can use. One application which I usually suggest is face detection, wherein given a video, I want to know the faces, who is all appearing in the video. That's an example of face detection problem. But if you can find the face and you can immediately say this seems to be a person who is not belonging to your location. Let's take you walk on the road, right? You see cameras everywhere and you see a face of a person. You have a suspect now, whether this person belongs to this locality or not. Can it say immediately this person is not to this locality, he's from other state? That could be most often anomaly situations which we want to solve. Second is malpractice detection. I'll show you what we have done in malpractice detection with our students. So this is more about given a video of a classroom where people are sitting. Am I able to find out what is all the malpractices that might come up? Person raising hands, person passing papers. Third is healthcare. COVID is the best example of healthcare, right? Today we have data of COVID coming up every day. Can we find out what is the trend of the growth of COVID? Which state is becoming alert? Which state needs to become alert? That means they might have cases in the coming days. So you can formulate it as a healthcare problem. You can solve it using deep learning. Next one, this usually is my area of interest. A packet going around a network, finding out whether the packet is having an anomaly or not. That means whether it belongs to a malware, virus. There you can bring in deep learning. Agriculture, there are different ways of looking at agriculture. One way of looking at agriculture problem is if I have sensors in a particular agricultural field, can I collect the values from the sensors and I can say given the temperature, given the water region, given the region of the particular place, this much amount of water has to be coming to the particular plant. That's a precision agriculture problem. Other way of agriculture problem is, as we are seeing in the last couple of days, we are getting information that certain insects come up which are able to spoil the entire cultivation. So if I have an aerial video which is going to have images of that particular region, can it say this is agriculture region that we are looking at, and in this agriculture region this much amount of insects have come up, so there's a possible damage of equivalent value. So it's an agriculture problem, but there the data is image data. Your analysis cannot help us. You need to do some analytics also. That means if the same set of insects are going to come up to a new place where there's a vegetation being available, in certain number of days, how much amount of cultivation will be getting affected? That is a prediction problem, which is more related to analytics. So agriculture with image data, you can call this image analytics also. Last one, which I usually discuss, this is for people to know why we talk about this video analytics, why are we talking about this deep learning and so on. See, models that we develop can be acceptable by us, but models need not be acceptable by the end users. So if you can develop a model as what the end user wants, that is as matching the business use case, then your model becomes very successful. Here I am bringing in the approach for you, which is towards call taxi booking. All of us know that we go through the mobile, we book a taxi wherever we want to travel. I give you a possible scenario. Now let's take you want to travel from your place to your home. There are two taxis on the UI, right, user interface. One taxi is 1 kilometer away from the taxi provider. The same taxi provider is having a taxi 5 kilometer away. Normal thing, if you put up a shortest path problem, you would say a taxi which is closer to you, which is 1 kilometer away, will be getting booked because the person is closer to you. But if it is a taxi which is 5 kilometer away, you would think that it is 5 kilometer away, it will not be getting booked. But the business use case to the problem will say like this. Every driver will always have an incentive based on the distance they have traveled. Let's take the driver has traveled 450 kilometers today on local, right? Now the provider of the taxi says if you reach 500 kilometers, you get 500 rupees as incentive, right? So the driver who is closer to you at 1 kilometer away has traveled 480 kilometers, right? And he needs just 20 kilometers to complete his trip to take 500 rupees as incentive, right? But the driver who is 5 kilometer away has traveled only 300 kilometers. So the business use case will say, don't allocate the trip to the person who is 1 kilometer away, because if he gets this new trip, he will travel 500 kilometers and you learn 500 rupees, right? So the trip will be generally booked to the person who is 5 kilometer away, because that person is traveled just 300 kilometers. So this is a business use case. So which to assign, which not to assign, we cannot go just by the algorithms alone. We need to go from the business use case of the user. So the business use case of the customer will actually say, allocate the taxi trip as much as possible in such a way that the incentives do not come. That's a general model. Just try to keep this for your information alone, right? Now, we will walk through some of the applications that we have taken up, right, with our team, which will get you an insight into deep learning. So the first one, which I want you to go through or understand, is more about malpractice detection, right? Now, as I told you, when you are given a video data, you are interested in forming some features. The features can be statistical features also. So there are a lot of statistical features. The primary features which all of us know would be something like mean, median, standard deviation, all that are examples of statistical features. Now, this problem was solved with one of my student, what I'm showing you, right, with my master's student. So what was our requirement was, can we develop a video-based system which will find out who is copying in the exams, right? This is a well-known problem to us. And if you want to know what is the problem that you are looking at, you should always understand the scene of the problem. So what is scene? It is like this. If you take a video, all of us will say that a video is a collection of images. So the more technical definition would be, say video is a collection of frames, right? Why do you say it as a frame? Is something like this. It carries the spatial information and it has got the temporal information also. Like you watch a video, it is very fast. Some video is very slow. That means there's a temporal information to the video. So every piece of video can be understood as a scene, right? Now, what we are interested in finding out is it possible for us to find the suspicious activities which are relevant to the malpractice which will happen in a classroom? What can be the suspicious activities? Somebody is looking into somebody's paper, exchanging papers, just movement of head, somebody standing up from their seats, okay? Somebody is trying to do some hand signal movements, small papers which they keep up in the hand just to look at copy, writing answers in hand. All this is called as anomaly. as I told you, which is abnormal is called as an anomaly. And in this use case of malpractice detection, all these are anomalies. So we look at developing a framework model which will be able to solve certain anomalies. So our challenge was like this. A classroom which is being placed where people are sitting, right? Is it possible to find out who are all raising their hand, as you can see here, and who are all the people who are trying to pass some papers, right? Who are all the people who are trying to pass some papers, right? So there you can see that these two people are trying to pass the papers. So your input is a video data. Now, when you look at systems like this, people usually ask about a question about the cameras. What cameras should I use? Where should be the cameras and so on. Usually you can have camera in the middle so that you get a 180-degree view of the given scene. What is seen is what is recorded from your camera. But there is possibilities for you to have multiple cameras also. So when you have multiple cameras, people usually suggest one camera will look at basically understanding the given video data, and other camera will look at tracking the given video data, right? For example, if there are two cameras facing towards your face, one camera will do the face identification, and the other camera will track your face as you are starting to walk, right? That's a general scenario. So you can have cameras wherever you want, but make sure that the purpose of the cameras is well understood. Now, with video analytics, people can talk about problems in different categories. Now, with the malpractice detection in front of us, let's see what we are doing. We have used a camera which is GT19100 camera, right? Which is 30 frames per second. Now, here we have used approaches which are based on holistic approaches like PCA. Then we have used some approach which are based on skilled color approach because we should be able to detect the skin pixels. Then we have gone with a path-based approach which is based on support vector. Now, what we are interested in seeing is, given a camera, can I detect a frame? And with the frame, can I do all these three? Head detection, motion tracking, then hand contact detection. Why hand contact detection? Somebody is passing a paper, it's a hand contact detection. Finally, there is an activity which is suspicious. So it is not a normal activity. So if it is not a normal activity, it is an anomaly. Show me that. That's a requirement of the system. So there are algorithms for face detection. So here we looked at algorithms which are based on Euler Jones, and we looked at algorithms based on AdaBoost. I'll come down to the results for discussion. Now this is your input frame, and right side what you see is a skin pixel algorithm. That's you have got a skin classifier. Using the skin classifier algorithm, it will detect the skin colors. But here you can see certain things also appearing as skin colors. Reason is, if you see the chair has a color which resembles to that of the skin color pixels. So it is also classified as skin color pixels. The tables, if you can see on the left side, okay, has colors which are resembling as of the skin colors, which is shown as skin color pixels. But right side tables are white in color, so they don't resemble as skin color pixels. So what we do is we go for a skin color recognition. That's your skin pixel algorithm, using which we'll recognize the skin pixels. Once we are done with it, our next requirement is to detect the faces, right? So as you can see here, the faces are being recognized. So this we have done it by using the LBP algorithm. There are some misclassifiers. As you can see here, closer to the right side of the window, you can see a lot of circles, but there is no faces there. But there is a possibility that somebody is standing outside. It is also recognized as a face. But here you can see that somebody who is sitting at the last is not recognized as a face. This is an example of a vision-based problem, right? My camera, with the data that it has taken, with the pixel resolution that is available, it's not able to recognize a face. It's a computer vision problem. So you can always look at this and see what are all the misclassification. Closer to the window, I see some circles. Below the table, I see some circles. All that are misclassifications. Then Improving the approach, we tried with hair cascade, where you can see all the people recognized with their faces properly. Right? The same challenge, we want to look at different resolution. If we want to try a different resolution, here we are talking about resolution of the images. Now see the difference here. In the left side, when we got with one specific resolution, we were able to detect all the faces correctly. But right side, when the resolution was changed, people at the last are not being able to detect it properly with their faces. The next is the eye detection here. As you can see, for every face, we are able to detect the eyes. But people at the last, we still have some challenge in detecting the eyes. Now, we went through the algorithm. As I told you, we can use performance parameters. The performance parameters will be based on the true positives and false positives. And our challenge was finding the accuracy. So when we went with the algorithms based on skin detection, we were able to get accuracy of 71%. FDP based was giving an accuracy of 81%. Hair cascade was giving an accuracy of 86%. So we were able to conclude that hair cascade has a higher level accuracy. So if you say you are developing a one model, then your accuracy should be greater than this 86% if my work is a state of art. Then next one was more about understanding the hand contact detection. Somebody is passing papers. Okay. So we went through an empty classroom. There we were able to detect the region of interest. As you can see here, for every table, there's a region of interest being detected. Then we asked the students to sit. Then we were able to again get the region of interest. This was done by using a background subtraction algorithm. Then, after getting the region of interest, we looked at a suspicious activity video. For example, somebody is trying to pass the paper. You can see on the right side, it immediately says this is an anomaly and the person is trying to pass a paper. I think people can see on the right side of the second image, right? There's an anomaly here because person is trying to pass the paper. This is one anomaly that we are able to find. The next one is most of the objective questions people solve by just finger movements. There are 5 choices, A, B, C, D, E. Show all the 5 fingers. It means it is A, B, C, D, E together, right? For example. So for every finger movement, we want to know what is the corresponding answer which the person is pointing. So our challenge was not finding the answer. Our challenge was is somebody trying to do a hand movement to the other person. So here we were looking at a color segmentation as a solution. So based on the color space model that we have went through with the theory, we proposed an approach and we were able to find the hand signaling. As you can see in the slide, whenever the hand signaling happens, there is 2 fingers rising up. Right side, it will be able to show that there's a finger action here. Same thing, all 4 fingers up, it shows you exactly that there is a finger action from the human being. So this is what we were able to achieve. So our use case in this video analytics application was finding the anomalies with respect to malpractice. What we are still trying to solve is, one is challenge with respect to computer vision. As I told you, somebody at the back is not visible. Can you still find out the actions of the particular person? It's a computer vision problem. Then next case is, there is no movement of the head, only the eyes alone move, right? So that's still very challenging that we are trying to solve. We have not got any success on that line. The third one is somebody is carrying bit of paper in the hand. Can your camera say that yes, he's got a bit of paper? Fourth one is somebody's written something in the hand. He's looking at the hand every time and writing on the answer sheet. So can you find it out? These are some the use cases in malpractice which we are yet to solve, which we are trying to do it. Okay. Then next one that we did is more about the emotion models, right? See, emotion is more connected to users. For example, if you ask yourself, what was your emotion on your face? Let's take at 9:30. It would have been very clear emotion. 10 o'clock when we have started looking for the session, right? Emotions would have started changing. When there was addressing from your principal, then the emotions would have changed. Now over time, the emotions would have got settled. And emotions are very important for any problem. So what we looked at is like possibly looking at emotions which are closer to the school students. Now this is more of a requirement, because when you look at emotions, general emotions are happy, anger, sad, and somebody says fear. But the challenging emotion is something called as neutral. If you ask certain people, and if you go to the people and say that you look happy, the person will say, no, I'm not happy, right? If you go to the person and say that he looks to be angry, the person says, no, I'm not angry. That means the expression that you conceive and what the expression the person expresses will not be same. So that's a misclassification in the expressions itself. And next is some person's face will be having a neutral expression. That means you cannot conclude what is the expression of the person at all, right? All that calls itself as something called as neutral expressions. So we were looking at finding solutions for emotion models for neutral expressions. So in that part, we looked at possibility of looking at school kids. Why it is very important is something like this. When a student is interacting with the software, like all of us are now trying to do a training or a teaching or an interaction with the student, and the student is expected to listen. The emotion the student expresses on the face will give us a lot of information. One information would be like the student is interested, not interested, the student is getting a doubt. Okay. Can you perceive the emotions? In this, positive emotions are very good. Negative emotions are slightly not a good factor, right? So what we were looking at is possibility of looking at negative emotions. In this process, what we looked at is a possibility of looking at all the tribal students. See, generally, when we go to schools, we see facilities with schools, kids coming to schools. But tribal regions, what happens is like students, facilities are created, but the students do not come. Students are insisted to come, they don't like to come. So how do you make a kid who is coming to the tribal regions to say that, yes, I'm interested in listening to something, right? It may be a lecture or it can be a story or whatever it is. So that was our thought process. So if you can detect the emotions of the tribal students, then it will help us to make them come to the schools. And it is possible for us to say that they have been able to learn. So we looked at two methodologies. One is in the algorithms, we have something called as keyframe extraction. This is very important from a video perspective, right? For example, let's take a person is walking, right, and suddenly falls down. So a keyframe will be a frame at which the person is starting to fall down. Okay. A person is listening, starting to sleep. A keyframe will be a frame at which the eyes are starting to close, right? So a keyframe is a subjective keyword. What is keyframe? It depends on the application that you go. So we were looking at keyframe extraction and then an emotion recognition. So in keyframe extraction, we looked at two algorithms, one based on PSNR based and other based on SIFT based algorithms. So given the video, we were able to run through and we were able to say certain number of frames are understood to be keyframes. So as you can see on the slide, total number of frames is 495, right? And out of which 480 frames have been taken and keyframes have been generated. So when you go through keyframe algorithms, please make sure that there are some performance parameters for keyframe extraction algorithms. One performance parameter is more about the noise. That's your error part. So we can see here that we have looked at two algorithms as we have shown you in the previous slide. One is PSNR and next is SIFT. So number of frames that we got after PSNR was 419. Number of frames that we got after SIFT is about 300. If you just go by number, you would say that 300 is good, right? Because 495 frames have become 300. But please always understand it's a subjective answer. If your 300 frames cannot give the information of the data, that means some important information in the data is lost, then people will always go for going for 419 frames, assuming that the 419 frames have not lost any key information from the original video data. So the interaction was something like this. We were interested in seeing what is the emotion of the people. So that's something called as positive, that's something called as negative emotions. So somebody puts a face up, right? It's a positive emotion. Somebody puts a chin down, that means your face is down, that means it's a negative emotion. for example. Like this, we were looking at emotions with respect to upper limbs, trunk, lower limbs, or like that. Our concern was more about the head movements. Right? So our model was like this. This is again a deep learning architecture model. So given your input, right, we got a lot of phases. Your DL architecture will give you something called as data augmentation. What is data augmentation is, given an image, we can create possible orientations of the same image. As you can see here, this is a face. The possible orientations of the face are shown here. This is called as data augmentation. Then, as part of normalization, we went through an illumination challenge and we went through approach for using a post estimation. Then the data is ready. So this is your pre-processing in the DN architecture. And this is your CNN architecture that we are showing you. So your data is given, right, with a predefined CNN architecture. We went through the model and it was able to say what type of expression the person expresses. As you can see on the right side, it will say whether it's a male or a female. Then it will automatically say that what expression the person exhibits on the face will be shown from the given set of expressions. The expressions that we took was anger, contempt, disgust, fear, happiness, neutral, sadness, surprise, right? So the given data that was given is falling into an expression of happiness. So again, as I told you, from a deep learning perspective, we have something called as input layers, we have hidden layer, we have output layer. So your input is given, and the hidden layers, what we talk about, can have a characteristic like convolution layer, or it can be a pooling layer. What you see here is something called as ReLU. ReLU is an activation function. So this is the parameters for the CNN architecture that was used. You can do a batch-wise training. So batch size is 32. Epochs, as I told you, is a number of iterations. Number of iterations here is fixed in the model. It is said to be 10,000. Number of classes is 7. That means we have trained with 7 classes of faces. Learning rate is a hyperparameter. And number of iterations is 900. Optimizer is a type of optimizer. Here is Adam, right? And the momentum has been fixed. Then the other activation function that we have used is ReLU. And CNN model that we have used here is bin exception model. As far as the layers is concerned, we have used 9 convolution layers and 2 polling layers. So with this data being provided, captured from the camera, it detects a person's face. Automatically it says what is the emotion of the particular person. And this is further presented in terms of the performance parameters. We were able to achieve an accuracy of only 66%, and we are trying to improve the model. So this is an ongoing work that we are continuing even with this year with our new batch of students. So in summary, what we have went through is what is deep learning, what are the concepts in deep learning, and I think I had given you a picture of what is deep learning related to machine learning and artificial intelligence. Then I went through 2 applications. One is emotion recognition, and next is malpractice analysis, which is again video analytics based problems. And in summary, if you are having a video data, as I told you, you can do pre-processing. You can apply keyframe extraction to extract the keyframes. So your input video, it is reduced into a certain number of frames. After doing a keyframe extraction, you can run through the algorithms which you have learned from image processing to find what you want from the data. Like you want to detect an object, you want to detect an animal, whatever it is. But in case you want to solve it as a video-based problem, like you want to know how fast a person is walking, how slow a person is walking, right? How quick a person is running. There you have to go to motion-based algorithms. So there are algorithms for motion suppression models, which you can take up. There, the motion component also can come as a characteristic to talk about this video data. Right? So that's it from my side. So thank you so much to the institution members for giving me the opportunity to deliver my session. If there's any questions, I'll take it up.
Thank you very much for the wonderful session, sir. I'm sure audience is definitely enlightened with your knowledge in this particular field. Now I request Professor Amrit Kumar to take over the question answer session. Over to you, Amrit.
Yeah, good afternoon, everyone. I hope this session was very useful to all the participants. And I request any participant who have any kind of doubts, any queries, you can ask them. The question answer session will be open for around 10 minutes. You can ask in the chatbot section or here. You can one by one user, any user can unmute themselves and ask the questions. Meanwhile, we get questions in the chat box, or meanwhile the users come in and ask questions. I thank Senthil sir for their valuable wisdom, sharing the wisdom with us. And the session was really into depth, and all the important factors were covered, almost all. And I would request anybody who is and having any specific doubts, doing any kind of research on a similar topic, any relevant question or queries, you can ask. The question answer session will be there for around 10 minutes.
Okay, there are some questions coming up. I'll try to answer. Am I audible?
Yes, sir, you're audible. You can go on.
Yeah. So is this deep learning applicable for distributed approach? People are asking. See, distributed as such, people should understand that there is a possibility that you can say that your camera is distributed everywhere. So it's basically of a collaborative camera model. Like you have 5 cameras in your home, all 5 cameras can try to see together saying that I am searching for a person, but the person is missing in the house. Okay, it's called as collaborative, right? It's a more of a distributed model. Any deep learning model can be formulated as a distributed model, as far as I know. So that's one question. Then, which deep learning model is suitable for a problem? There is no answers. One is like people will say that let's take you're going for object recognition. People will say YOLO is the best model, for example, for object recognition. If you can overcome YOLO and you can say that yes, I have developed a new model, it's a good way. Or as I told you in the beginning, based on your problem that you work, whether it is solved or unsolved problem, you can always feel satisfied that I am taking my first step. So my first architecture that I'm trying is my good architecture. So with that, you can move on. Then you can try to go and see whether your performance in the architecture can be improved. Okay. Next question is like, how do you determine the features which are important for feature reduction? That means the dimensionality reduction. Usually it is left to the data algorithms, right? If you go to PCA or autoencoder, they will help you to automatically eliminate the features. So you need not worry about which features are important, which features are less important. I saw 3 questions. Any more questions? Okay, what is the difference between big data? I'm not able to get the question. What's the difference between big data versus and machine learning? I think they are asking. See, please always understand no data can become big data at one point. Like for example, if you talk about the COVID data, back in December, we have limited data. Then China was the first person to say, I have a sample data, my population has got affected, now my population doesn't have a COVID. So there's a graph, there's a downward trend on the graph. Now, if you ask about like, do you have a COVID data? You would say, yes, I have for all countries, all states, everywhere around the world. So any data that can grow with time is called as a big data problem. So whenever you have a problem, just see whether your data will grow with time. If it can grow with time, then you can assume it as a big data problem and you can go ahead with your model development. Any queries?
So there's one more question popping up. Another question that is, which is more effective approach, deep learning or machine learning, sir?
Okay. See, as I told you, see, every one of us think that, okay, deep learning is a solution. It's not like that. Whenever you have a problem data, most of the problems can be solved with root-based systems. For example, if you go to the IT industry, they will say that still decision trees are the best algorithms. So what I would suggest to you is just see whether your problem is a discrete problem. If it is a discrete problem and solvable, right, just go back and check whether decision trees can work. If decision trees cannot work, then take an approach in machine learning. If the approach in machine learning is not able to give you the effectiveness, what is effectiveness is whatever you expected in the result, like a precision should be better or accuracy is better, is not achievable, then you go for deep learning. What is the use of normalization? How it will affect the image? Okay, good. See, normalization as such, we should be able to understand that information extraction is an important thing in any data. Normalization is more for understanding the information extraction process.
So one interesting question is,
Yeah.
Is it possible to recognize emotions by using speech?
Okay, yeah, people are working actually. See, when you have two types of data to solve a problem, it becomes a multimodal data, right? For example, with the speech and the face of the person you are trying to solve, speech is one data and your face is another type of data. It becomes a multimodal learning problem. It is possible. People are working with speech and face recognition for emotion analysis. One more question is people are asking like is it a trial and error approach deep learning? See, it's not like that. As I told you, if you go to the model, you can fix your epochs and you can be happy. Yes, I fixed 1,000 epochs, I got 70% accuracy. It is fine. Or otherwise, what people do is like the hyperparameters, which I was saying you again in this presentation, I stressed hyperparameters that you specify, learning rate, activation function, and so on, they can actually be fine-tuned. You can have learning rate as 0.1, you can have learning rate as 0.01, or you can try to see between this 0.01 to 1, what is the point at which the loss was very minimal. That can be a parameter that can set into the model. So you can formulate an objective function, and with the objective function, you can fine tune the hyperparameters. And with that, you can conclude, yes, my model is perfect. Any questions? I'm not getting any questions, but from my side, my thanks to institution and thanks to Amit Kumar and head of the department principal for getting me on board to deliver the session. And further, please feel free to write me a mail in case you have any basic things as doubts, or if you want to work with any of my students' activities in the sense like the projects that we are looking at, like practice or some other automations that we develop, you are interested to work, please write me a mail. We can officially see the process, and your students can also work with me in the ongoing projects. That's
Hello.
all from my
Yes,
side.
sir. I
Thank
you on behalf of the institution, sir. And a lot of chats, messages coming that the session was very informative. And they're thanking you, sir. And today, for the participants, I would like to say that today was the session from an academician, well-known academician. And tomorrow, and day after tomorrow, we'll have two industry people coming in. So I wish we'll get the same participation level tomorrow and day after tomorrow as well. And sir, there's a lot of requests from the participants to share the PPT as well. So is it possible from your side, sir?
Yeah, I'll be sharing the presentation, sir, to you. No problem. It will reach to them. Nothing to worry.
Okay. So I would like to convey all the participants that we'll take all the important content from the sir and we will mail you individually. Thank you, sir. Anything else that you want to convey to all the participants, sir?
Thank you from my side, and be very positive. And I don't know the audience, students, researchers who are in this field. Please walk with the data, then analytics will be very interesting. If you disconnect data and see analytics, then it will not be interesting. Okay, because when you do a lot of other analysis, our analysis is correct or not, we can understand only when we have good understanding on the data. So my suggestion is, whatever problem you're working on, please spend a lot of time in understanding the data. Build your data with as much as possible challenges, positive, negative samples, lot of noises and so on. Then you build your model. Then you'll feel it nice that you get good results. That's all from my side. Otherwise,
Hello.
I'm growing with the way. Thank you so much.
Hello. Hello.
Yes.
Yeah, sir. In image, they always maintain a mean equal to 0 and standard deviation equal to 1. Why? It's like that, for what purpose?
Okay. Again, ma'am, that is actually related to the information that you want to extract. It's a common rule. If you deviate from that, what will happen? You can see, the normalization will not be possible.
Okay. What is it? Just for information extraction it is?
Normalization.
Yeah. Okay.
It's for normalization purpose, ma'am.
Okay.
Okay, anybody else who want to ask any further questions? Okay, I think that's it, sir. Again, sir, that was well said. Walk with the data and video and analytics would be interesting. I like that frame, sir. And again, sir, I would like to thank again all the participants to remain connected with us throughout the session. The participation was continuously monitored and it was the regular. So I hope the participation will remain tomorrow and day after tomorrow as well. And all the content will be shared to you by mail. We are thankful that Senthil sir is ready to share his valuable content that he has shared. So that's all from my side. And any more queries on such topic, you can contact on the details given on the brochure, and queries will be addressed. And as sir mentioned, he will be sharing his personal contact details as well. So you can contact him anytime. And by us, through us also, you can contact Senthil sir in future time. So I thank all the other participants for joining us. Thank you. Thank you, Senthil sir as well.
Thank you, sir. Good day. Thank you. Thank you.
So thank you very much, Dr. Senthil, sir. We
Yes,
hope
sir.
in future also we'll be connected with you, and
Yes,
we
sir.
expect the same cooperation in future also, sir.
Yes, sir. Yes, sir. Sure, sir. Pleasure.
Yes, sir. Thank you, sir. Thank you very much, sir.
Thank you so much. Good day.
I request all the participants to leave the WebEx session now, and you'll soon get the attendance
I request
sheet.
all to fill the attendance before leaving. Attendance link is shared in the chat box. Just click and mark your attendance, and we'll see you back tomorrow. Once again, I request all the participants before leaving the room, you mark your attendance. The link is shared in the chat box. Use that link to mark your attendance. And tomorrow's session will start sharp at 10 a.m. Good. It was a very good session, sir. Very nice. His presentation and all was very good, actually. Very live examples also he showed. Amrita को बोलेंगे immediately. It will be some. Amrit sir, are you there? Amrit? Amrit, are you there? Suhas sir, are you there? Host, he is host.